Good morning to viewers. We are really interested in going for the second part of physical world. Already we have learned what is meant by science and what is meant by physics. What are all the 6 learning outcome by which science and physics are really dealing with. Now we are moving on to the excitement, scope, and the different aspects of physics. Now let us get into the lesson. Dear viewers, Enrich Tamil is exclusively for Samachi students. Why I am saying this, it is exclusively for Samachi students is basically 3 important things. These students are having no access to the reference material. But if you are really able to provide them the reference material, then automatically they can able to do wonders. See, the 7.5% rank list published by the Medical Council. The first rank, second rank, third rank, all the children from government schools are scoring around 500 and something marks, which is practically considered to be the best mark in 2017 for the regular students. So now the government school students can also be able to rise up to the benchmarks. But only one thing, remember, the children's attempted second time and achieved the same. So these particular videos are really going to be helpful for the first time achievers through the NEET. Now let us get into the content. Dear friends, these are all the 5 important areas the physical world is encircling around. What is physics? What is the scope and excitement of physics? How physics is related to the technology and how it is useful to the society. How physics is really being compiled. We already said the 2 major thrust areas of physics as unification and reduction. Now we are going to say how hypotheses, how axioms, how postulates are really going to compile the physics into one very, very important subject area. Basically, matter and energy were studied in physics. Now we are going to analyze in this particular content area the forces, contact forces, non-contact forces, then we are going to generalize. Of course, at last, how the physics laws are really made, what are all the basic assumptions, what are all the postulates, how physics can able to contribute the understanding for the nature. Now, the content already we have learned in the part 1 can be approached in the different way. We are going to see the things now. These are all the major content area what we can really learn. There is always up to the mankind for the last 20 centuries, nature versus mankind is going on. Through the scientific method, mankind unfold the pattern and the facts about the nature. The pattern and the facts about the nature were told before 16th century as a philosophy. The proved fact after 19th century will be called as a science. And then one important thing, whatever may be the science laws and definitions, postulates and everything is a ever-changing science. So what is physics? Physics is nothing but a study between the matter and energy. It is actually physics is a branch of physical science which is studying the properties of matter. The major thrust areas of physics are unification and reductionism. Classical physics or the modern physics are the 2 major areas which are going to cover the 3 important domains called macro, meso, micro. Now let us get into the thing. Basically called science is really originated from the word to know. or otherwise we can say it is nothing but the knowledge of science. And in very specific manner, we can say it is nothing but understanding the nature. Science helps the mankind to understand the nature. Now, we will approach the whole content 1.1, what is science and what is physics, in a different way. Suppose we do not know the rules of chess, but we are allowed to watch the moves of the players. Let me suppose we are watching the chess game. We are unknown about the rules of the chess. When we watch the game for a long time, we may not make out some of the rules, but generally we can be able to find what are all the techniques by which the players are really moving. When a player is moving a particular move, whether it is right or wrong, we can be able to say with the knowledge of the rules. But very, very difficult task. Without knowing the fundamental rules, we cannot predict the flow of the game. So, even if we know all the rules of the chess, it is now so simple to understand all the complication of the game in each situation and predict the correct move. For example, we are watching a game, a player is making a move, and under what situation the player is making the move is the individual decision of the player. Now, as an expert, we will analyze and we say whether the move is correct or wrong. So, science is one, knowing the basic rule of nature. Knowing the basic rule is, however, the minimum requirement of any progress is made. Though we may become a scientist, we may become an engineer, we may become a doctor, we must know the basic rules of science. Understanding the nature really needs the basic rules. Science provides the basic rules. Mankind uses science to understand the nature. So, H.C. Verma is a very, very, very interesting author. He really says that nature is playing a game. Mankind is a person who is watching the game. He deduces some rules. He deduces some laws. He deduces some principles. But all the rules and principles are without knowing all the fundamentals. So all the findings, all the rules, and all the laws are subject to the change that the nature is going to exhibit. This is what the outcome of 1.1. So physics also goes in the same way. Nature around us is like a big chess game. Nature is playing the big chess game. The events in the natures are like the moves of the great game. We are allowed to watch the events of nature and guess at the basic rules according to which the events is really taking place. When a player is playing the football, we are watching the football without knowing the basic rules. We are really astonished to see why a player is moving as such an astonishing move. But we cannot justify the move. We cannot say as an expert, this move is correct or wrong. So we may come across new events which do not follow the rules guessed earlier, and we may have to declare that old rules inapplicable or wrong and discover the new rules. Very simple. Nature plays a game. Mankind watches the game. Mankind, after careful watching, can able to deduce some rules. Based upon the rules, he can able to say whether the player move is correct or wrong. It may be correct or it may be wrong. So sometimes, after knowing all the rules, we can be able to say the move is correct and the move is wrong. So every time the move that the player makes us to understand the nature much more deeper. This is the content of 1.1. Very clear? Now let us get into the things. Physics is the study of nature. Of course, physics discovers the rules that are operating in nature. For example, in chess, castling is one kind of rule. We may not know unless otherwise the player do it. We can able to know, is it a correct move? Is it under the rules? Likewise, tsunami, volcano, lot of things are exhibited by nature. We discover the reasons. Aryabhatta, Newton, Einstein, Feynman, all the great physicists, from the observations available at the time, they can guess and frame the laws of physics, which are explained by the observations in a convincing way. But there are new phenomena any day, and if the rules are discovered by the great scientists are not able to explain this phenomena, no one will hesitate to change the rules. That is the beauty of physics, beauty of science. So, nature is playing the game, mankind is observing the game, deducing the rules, discover the rules. But these rules are applicable if and only if the playing pattern is such a way that it governs under the rules. But if the play exceeds and do it in a different way, then a different rule can be framed by the same observer. That is the nature of science. So, science discover one fact. If somebody disproves the fact, then automatically science modifies themselves. So, scientific method. Nature exhibit a property. The property is analyzed by a scientific method by means of systematic observation, controlled experiment, qualitative, quantitative reasoning, mathematical modeling, prediction, verification, or falsification of theories. So, physics studies the nature. Physics studies the non-living things matter and then forms the laws, forms the hypotheses, forms the axioms, forms the postulates. These postulates, laws are subject to change by the new generation. So, physics already we know, which is nothing but study of matter. The scope of physics. Universe is expanded in three major domains. The first domain is called macroscopical domain. The second domain is called microscopical. Macroscopical domain includes laboratory, terrestrial, and astronomical. Microscopical domain includes atomic, molecular, and nuclear phenomena. So, recently, macroscopic is divided into mesoscopic physics. So, macroscopic, mesoscopic, microscopic are the three domains in which universe is spread. Physics is really interested in finding out the non-living things properties in these three domains. So, macro, which deals with actually astronomical one, meso deals with real world, micro deals with atom, molecules, nucleus. So, all the three domains compiles the universe. Physics is really interested in studying about and formulating the laws in all the three domains. Macroscopical really deals with terrestrial and astronomical. Microscopical deals with micro world, atom, molecule, and nucleus. Actually, physics can be classified into two ways: classical physics and modern physics. Macro, terrestrial, astronomical falls under classical physics, but atom, molecule, nucleus falls under modern physics. So, classical physics major areas are mechanics, electrodynamics, optics, thermodynamics. These are all called the major areas in classical physics. But whereas in the modern physics, atomic physics, nuclear physics, atom model, nuclear reactions, fundamental particle, all falls under modern physics, which may be otherwise called quantum physics. So, physics, microscopical, macroscopical. Microscopical deals with quantum physics, theory of relativity. Macroscopical deals with mechanics, thermodynamics, electrodynamics, and optics. So, we are coming to the next area. The next area clearly says scope of physics spread into three domains: macro, meso, micro. The study of the macro level physics is nothing but classical physics. The study of micro level physics is otherwise be called as modern physics, in which we are really dealing with quantum mechanics and theory of relativity. So, the domain we are really describing, macro, micro, meso, is really defining the dimension of the domain. For example, when we are really saying the size of the nucleus, it will be around 10 power minus 15 meter. But whenever we go to the size of the planet, it will be around 10 power 7 meters. When we go to the universe length, it is 10 power 26 meter. So, if length is the fundamental unit, whose range will be from 10 power minus 15 meter to 10 power 26 meter. So, physics deals with a huge domain area. Length is an area which is ranging from the size of an electron, size of a proton to universe dimension. So, length dimension varies from 10 power minus 14 minus 15 to 10 power 26 meter. Likewise, we can also say there is a large difference. Minus 14 to 10 power 26. 10 power 40 is the range, the gap between the 10 power minus 14 meter to 10 power 26 meter. Another thing, time scale. Time scale ranges from 10 power minus 22 seconds to 10 power 18 seconds. For example, the time taken for a planet to revolve around the sun, time taken by the light to reach the earth, light years, so many things are there in the time scale. Regarding the mass of an electron is of the range of 10 power minus 30 kg. Mass of the universe is around 10 power 55 kg. So, terrestrial phenomena lies in between. So, length scale, time scale, mass scale, if we observe the domains, it may vary from minimum level to maximum level. The gap may be around 10 power 40. So, scope of physics is really extending from macroscopical to microscopical. For example, physics deals with atoms, nucleus, electron, fundamental particle to planet, satellite, universe. So this is the wide area. So the scope is actually the range of length ranges from 10 power minus 14 meter to 10 power 26 meter. Range of mass from 10 power minus 30 to 10 power 55. Range of time is 10 power minus 22 to 10 power 8. Terrestrial phenomena lies in between. Very, very important things. We have already told you, physics spread in so many domains. Physics is having the very large range of measurements. What is the excitement is, the basic laws are very, very simple, but it is applicable to all the three domains, so it may be called as the universal one. It is a source of wonder that the vast realms of experience can be summarized in a single sentence of equation. For example, if a particle movement in whatever may be the domain, it can be defined by Newton's law. Whatever may be the matter energy conversion may be very simply told by Einstein, mass energy relation E is equal to mc square. The most incomprehensible things about the universe is incomprehensible. Actually, no number of experiment can prove me right. Whenever I really postulate a law, I really postulate a very, very important mathematical equation. Any number of proof I can give, but a single experiment can able to disprove my things. That is the excitement of physics. Physics spread into three domains. The range of physics is very large. In spite of all the things, physics is very simple. By a simple law, by a simple mathematical equation, physics can explain the whole phenomena in all the three worlds. So physics is nothing but a simple law that can able to govern the universe. But only one thing, the law is subject to change. Whenever new experiment found, the law is wrong, the equation is wrong, physics is ready to change. Nobody governs the physics. So exciting physics excites in very, very important ways. People are really being excited by physics because of the simple laws. Because of using the simple laws, so many useful devices are really being devised. So the ingenuity, persistence of the scientists really made physics are so simple that every mankind understand. But the elegance is, but the beauty is how physics really able to summarize the facts about the nature and can able to make the law applicable in all the three important domains. So physics is really nothing but very precise measurement. Either it is an atom, or it is a planetary movement, or it is a universe movement. Wherever the movement, wherever may be the range, physics deals with the precise measurement and also it deals with approximation. To derive at the conclusion, it approximates the measurement and can able to arrive at the concluding laws, concluding mathematical equations. So for example, free fall of gravity is one kind of example. A feather and a moss. When the feather and the moss falls in gravity, irrespective of the mass, both are supposed to fall in the ground at the same time. But air resistance plays a very, very important role. For example, when the experiment was done in vacuum, automatically we can able to infer mass independent is the free fall gravity moment. But air resistance really plays different. So physics backs the approximation. Neglecting the air resistance is going to define the free fall of gravity is not depend upon the mass. So we learned another important area. Physics spread into three worlds in the universe: macro, meso, micro. The study of the macro world, lab, terrestrial, astronomical world, we call it as a classical physics. It contains so many branches: mechanics, electrodynamics, optics, like that. Another very, very important domain is micro. Modern physics, quantum physics are the really very, very important areas in micro domain. So the range of length, time and mass ranges from very, very small value to very, very high value. Physics deals with big range of measurement. Even though physics really aims at precise measurement, it really approximates the measurement so that it can be able to deduce laws, definitions, and uses. So the major thrust area, physics studies the nature. Physics deals with the matter and the energy, the relationship between the matter and energy. The major thrust areas of physics are unification, reductionism. Physics, after careful observation of the nature, can able to predict a law which may be applied in all the three domains. That is called unification. Physics can able to identify so many laws: Boyle's law, Charles' law, and other things. Law of thermodynamics 1, 2, and 3. All the laws can be simply defined by kinetic theory of gas. So it is called a reductionism. So a simple law can able to give the reply to all the findings that were already made. So compilation is a very, very important nature of physics. Laws, principles, hypotheses, axioms, and postulates are the guiding force of physics. Physics observes the nature, observes the matter and the non-living things in the universe, and identify laws, principles, hypotheses, axioms, and postulates. Now let us see what is meant by hypothesis in physics and mathematics. One should not think that everything can be proved in physics. We already told you difference. Philosophy is the facts known from the ancient times. Science is nothing but in 19th century we said science is nothing but proved facts. We should not imply that all the facts in science, all the laws in science can be proved, but all the physics and all the mathematical laws are based on some assumptions, each of which can I variously called as hypothesis, axioms, or postulate. In order to derive a law, in order to derive an equation, physics makes some assumptions. These assumptions are called hypotheses or axioms or postulate. For example, Newton's universal law of gravitation proposed by Newton has got an assumption or hypothesis. So the universal laws of gravitation says that if you assume that any two bodies in the universe attract each other with a force proportional to product of their masses and inversely proportional to the square of the distance between them, then we can explain all this observation in one stroke. But a hypothesis, a supposition, without assuming that it is true. It would be fair to ask anybody to prove the universal law of gravitation because it cannot be proved. So, with some assumption, universal law of gravitation has come with a formula. Force is proportional to the product of the masses. Force is proportional, inversely proportional to the square of the distance. F is equal to G into M1 M2 by R square. We can be able to prove with the formula, we can be able to calculate the force and experimentally prove it is right. But the hypothesis cannot be proved. It can be verified and substantiated by experiments, substantiated by observation, but the assumptions cannot be verified. Are we in the right path? Newton's law of gravitation is applicable to all the domains and it may be called as the universal law. But the universal law is based upon some assumptions. The assumption can be able to give us an equation, F is equal to G into M1 M2 by R square. The equation can be verified, proved by experiment, proved by observation, but the hypothesis cannot be proved. Actually, we can be able to say one step further. In order to explain a scientific fact, scientists are usually defining a model, liquid drop model, Bohr atom model, Sommerfeld atom model. All these models with certain postulates can be able to define the properties of the particular things. Atom properties are very well be explained by Bohr atom model, Sommerfeld atom model, and all other atom models. But what we really say, there are large amount of spectroscopical data before us, but axioms define a model that can be able to explain the spectroscopical phenomena, but only one thing, the assumptions or the postulates cannot be proved. With the postulate, we can derive the radius of atom, we can derive the energy of the electron orbit, all of the things can be proved and experimentally verified. Postulate. For example, Einstein's special theory of relativity is based upon the two postulates. The constancy of the speed of the electromagnetic radiation and the validity of the physical law in all inertial frames of reference. Speed of light is constant. Speed of light in vacuum is constant. Independent of the source of the observer is the basic postulate. Likewise, in mathematics also, large number of postulates are really being available. Now we make it very, very clear. Physics uses unification and reductionism. Physics deduce laws, equation based upon hypothesis, axioms, and postulate. So We will conclude the second part just by saying physics falls under three important domains: macro, meso, micro. Classical physics studies about the macro world, meso world. Modern physics deals with micro world. Macro, micro, meso world has got a large number of range, length, mass, time. These fundamental quantities are having very big range because it really takes into account the atomic micro dimension to astronomical dimension, which is called macro. Another very important fact, physics is a very important one which studies the matter and energy, which can be able to deduce laws, deduce equations, deduce so many things. One is physics facts are proved in the laboratory. Physics facts are based upon some assumptions. These assumptions are called hypotheses. A model is proposed based upon the model physics laws can be derived, which is called axioms. Kinetic theory of gases, Einstein theory of relativity, based upon some postulates. These postulates cannot be proved, but the results can be proved. This is the understanding of physics. Okay. Now, we are really closing the last part. Before going up to the next part, let us make it very clear. What is science? What is physics? How physics is really relating the nature and studies the nature, and how physics are really being made up of. Third, very important things. What is the scope of physics? What is the range of physics? Physics spread into physics spread into three domains that comprises the universe. The range is micro to macro. In all the domains, in all the ranges, physics can able to derive a law. If that law is applicable to in all the domains, then the law is called universal law. Thank you for the second part. Let us go into the next part. Thank you.